Hello class. For today, we're going to be talking about permutations, and you will be doing a more intricate permutation questions for today's assignment. Yesterday, we have talked about how there's both permutation and combinations, and how one of them has what we call order matters, and one of them has what we call order does not matter. So for permutations here, when we're going to do these problems, I need you to take a look at the context in which what you're given, because most often than not, when I give you these questions, they're all going to be falling under the category of getting them in line, or if we're talking about, like, let's say a lock combinations, that's one of the big ones. Or when we say that we're getting group of specific positions. So you will see examples of these three kinds where I ask you to get 8 student council members, but I tell you to get in a group of 3. That is not a permutation question. I tell you get in a group of 3 specifically of president, VP, vice president, and secretary. If I ask you to specifically put those 3 categories in order, then you will know that it's a group of specific positions, which that means that it's going to involve a permutation question. Okay. Now, example, we're going to be taking a look at for something like this. A computer password, a lock code, if you will, is to consist of 2 lowercase letters followed by 4 digits. So I have 2 letters and followed by 4 digits, 2, 3, 4. Okay, so this would be an example question. So determine how many passwords are possible if repetition of letters and digits is permitted. So first of all, when you're given these questions, you just have to automatically know something that's already implied. How many letters are there in an alphabet? 26. And how many digits are there? That's a total of 10, not 9, because we're counting from 0 to 9. So determine how many passwords are possible if we have repetition of letters and digits is permitted. So out of these 6 spaces, what are we going to do? We're going to say, okay, 26 letters are for the possible for first and the second letters. Then it's followed by 4 digits, which means there's going to be 10 in each of them. If we're using the formula from yesterday, it's NPR is equal to n factorial over n minus r factorial, correct? Well, you have to do this twice for letters and numbers, or digits, if you will. For letters, it's you have 26 things to choose from, and you're literally choosing it. Well, actually, no, the formula will not even work because it's actually repeated. So if the repetition is permitted, then this formula is actually no good. You actually want to write down the list of blanks and find out how many possible ways are there and then just multiply through. And when you type that in your calculator, what you're going to get is that it's 26 times 26 times, how many zeros is it? 2, 3, 4, 10,000. So that's approximately in total 6760000. So about 6.7 million ways in which that way could happen. Repetition of letters and digits is not permitted. So if it's not permitted, then what's going to happen here is that you're going to get numbers that's going to be 26 letters that's 26, but one of the letters is actually used. So you're going to have about 25 letters afterwards. And then for numbers, you have 10 digits, but what's going to happen to every subsequent number? Well, you can't reuse that number, so it's going to be 987. So when you say 26 times 25 times 10 times 9 times 8 times 7, you're going to get about 3.2 million. To be exact numbers, it's going to give you these many ways in which that could be arranged. Okay, so make the blanks and then fill in those numbers and then just multiply at the end to find out how many total ways are there. So this would be an example of a lock combination question. Okay. The second example that I want to show you is assigning them into a line. So if I want to get them Bob, Sue, Larry, Sally, Fred, 5 people in a line, how many different ways can they stand in a line? Now this type of situation, you'll be able to use a permutation question, and it's going to be simply the formula that you can use is NPR is equal to 5P5, because I have 5 spaces to choose from and I'm aligning all of those 5 people, and I want to find out how many ways in which that's possible. So there's 2 ways. Either you could do this, or you could draw 5 blanks and fill it up with 5, 4, 3, 2, 1. Now, if you were to do this, 5 times 4 times 3 times 2 times 1, I believe that's going to give you 120. But if you do 5p5, the formula is 5 factorial over 5 minus 5 factorial. Now, 5 minus 5 might seem weird, but that's going to be 0 factorial, correct? Well, 0 factorial, believe it or not, is actually just going to be 1. Okay? So 5 factorial is 5 times 4 times 3 times 2 times 1. It's exactly the same thing as we have done there. So my final answer will be 120. Now, if specific people are in the way of getting you the permutation numbers, then what do we do? So for example, how many ways can they line up if Larry insists on being in the middle? So if I have 1, 2, 3, 4, 5, and if Larry insists on being in the middle, that means that Larry has to be the one that's in the middle right there. Now, unfortunately, I won't be able to use the NPR like I would have done. I still have to use the blanks to do my problems, and that would be the best way to do so. So if I have if I have Larry in the middle, and that's finalized, I have to prioritize this. Okay, so Larry is out of the picture. That means I have Bob, Sue, Sally, and Fred. So how many people is that? That's 4. So in other words, if I'm arranging 4 spaces and I have 4 people to choose from, then I can simply do, okay, so the first space I can have 4, then I can have 3, then I can have 2, and I can have 1. Now, look at the numbers here. I know it's not in order like we used to have, but this is perfectly okay because as long as we prioritize that one person being in the center, then the rest of the people doesn't matter, right? So I just have to fill in the blanks and I just have to, you guessed it right, you have to just multiply them. 4 times 3 times 1 times 2 times 1 is going to give you 24 ways. Try part C on your own and pause the video now and let me know when you're done. Okay, so for this question, what we want to do is we want to make sure that Sue insists on being first and Bob has to be last. So if I were to draw those 5 marks, let's say, I'm going to use purple here. Let's say 1, 2, 3, 4, 5. I want to make sure that Sue is the first one and Bob is the last one. So those 2 people, those one person, has to be in the first and the last. That's finalized and it's prioritized above all of the other people. So now what I'm going to do is I'm going to have Larry, Sally, and Fred. Those 3 people arranged in these 3 spots. So 3, 2, 1. So when I multiply these numbers together, I get a total of 6 different ways. And that should be the final answer. Okay? So make sure if they actually give you a condition, okay, this is called a condition in which a specific order must be matched, you need to prioritize that and consider that into your permutation first before you do anything else. Okay? Next question is the last question that I've given you, the topic in which I give you specific order of club consisting of 8 members, president, vice president, secretary, just like the example that I've shown you, right? How many different arrangements are possible? This is actually quite simple, is because I have 8 people to choose from, but I want to have 3 people specifically in that order. So you will have the toughest part about this topic is whether you determine this is a combination versus a permutation question. Obviously, for today's topic, I told you that we're only going to be dealing with permutation, so you know that you're going to be using this formula, 8p, and you're choosing 1, 2, 3 positions, so that's going to be 3. You know it's going to be permutation because why? Order matters. Why does order matter? Well, because if person A becomes president and person B becomes vice president, and if you reverse the order, this and this actually means 2 different scenarios. Okay? If Mike Pence was the president, if Donald Trump was vice president, then we'll have a whole new country running up in this place, right? So the permutation matters. The order matters. So then order matters. So that's why how you know you're going to be using permutation. So that means it's 8 factorial over 5 factorial. I just did it a little quick, 8 minus 3. So that means it's 8 times 7 times 6, 5, 4, 3, 2, 1, over 5, 4, 3, 2, 1. All of these will cancel out, so you're really doing 8, 7, 6 multiplied. So that's how much is that? 336. Or you know the 3 spaces to choose from, 8 people to choose, 7 people to choose, and 6 people to choose. You're going to multiply them and you're going to get the same answer that way. Okay, so make the blanks. Okay, that way usually works out most of the time. Sometimes if you want to use the formula, but then sometimes like in these case scenarios, like the formula cannot be used, it's not going to be quite useful. For these cases, you will be able to do so. Okay, now this will be your final question. Pause the video and make sure you get the question right. I believe that this is pretty simple. NPR, this is 10P3. So you have 3 spaces to choose from, 10, 9, 8. That's going to be 720 ways, okay? Unfortunately, this is one of your homework questions as well. So if you have seen this video, then you have your answer there already, okay? All right, make sure you finish your assignment by 11:59 p.m. today. And thank you and have a good day.